Hello, hello, hello. Good morning, everyone. Mega love shout out all the subscribers and followers of this channel, especially to all my students, and this is for you. Okay, let us continue our reviewer for the third quarter exam. So, again, this is your teacher, Marife Adonis. Okay, so this is a continuation from part 1. So, if triangle QRP is congruent to triangle STU, and segment PQ, no, so this one is congruent to segment ST, then the measure is equals to, so if you're going to get the value of M, so we have M is, or 2M plus 1 is equal to M plus 6. Alright, so combine like terms, so 2M minus M is equals to 6 minus 1. So therefore, we have 1M, or M is equals to 5. So the answer is letter D. Okay, next. Now in number 26, what is the length of ST? So ST, we previously said that that's M plus 6, no? So therefore, if your M is 5, uh, 5 plus 6 is equals to 11. That's letter C. Okay, next. So in number 28, we have triangle PQR. What is the included side of angle P and angle Q? Okay, angle P and angle Q. So we have here uh, PQ. Therefore, the included side is PQR, included side. So we have triangle. Okay, so it's better that we drew this. So for example, this is your triangle, and then we have PQR. Now, if we have triangle here, two angle, I mean, this is the included side, no? That is PR. Okay, PR is the included side. Next, we have what is the properties illustrated in if angle A is congruent to angle B, then angle A is congruent to angle A. So that's reflexive property. Yeah, it's a reflection of itself. Next, if triangle ABC is congruent to triangle DEF by its postulate, so we have a segment AB is congruent to DE and BC is congruent to EF. What is the remaining pair of congruent? Therefore, C or AC is congruent to DF. All right, next. Okay, so which of the following statement is true for SAS postulate? Two sides and included angle of one triangle are congruent to the corresponding parts of another triangle. B, two angles and the included side of the triangle are congruent to the corresponding parts of another triangle. C, two sides and one angle of the triangle are congruent to the other part, or two angles and one side of one triangle are congruent to the corresponding parts of another triangle. So, it looks na parang lahat tama, pero we could say that this is ano, so two sides and an included angle of one triangle are congruent to the corresponding sides of another angle. Okay, letter A. Next, what does CPCTC mean? So it also means that corresponding parts of congruent triangles are congruent. Letter A. Next, triangle PQR and triangle XYZ are congruent by A is a postulate. If angle B or angle P is congruent to angle X and angle R is congruent to Z, what included side must be present? So we have here, if you have to, okay, so included side, so we have angle P to angle X. angle R. So that means we have PQ and AY or XY. PQXY ito. Okay, next. If and triangle TOM and triangle JAR to say TO segment, and then we have what triangle congruence proves that these two triangles are congruent. So that is side angle side. Okay, side angle side. Dun, dun, dun. Okay, what angle is included between segment AB and segment BC in triangle ABC? Okay, included. All right. So we have here uh AB, AC, and then so we get angle A or triangle. What is included angle? Okay. So we have here A B C. Okay, if this is your drawing, so we have AB and BC. Therefore, the included angle is angle ABC. This one, okay? Next, the longest side of the right triangle is called hypothesis. What is the hypotenuse in PQR if measure angle R is 90 degrees? Therefore, PQR, the hypotenuse P. Okay, so if you have the right triangle like this one, we have PQR. Okay, this is a right triangle. Let's imagine a right triangle. Okay, so this is the right triangle here. That it should be PR. PR or RP? Okay, PR or RP, correct? Well, I will choose PR. Okay, given PQ or PA is perpendicular to YZ at Q and segment PY, PY. Okay, PY is congruent, no? So this is congruent to PZ. Which theorem will is used to prove that triangle PQY is triangle to PQS? So we could use here HA or hypotenuse angle theorem or hypotenuse leg theorem. So which do you think is the correct answer? Okay, so we shall use HL theorem or hypotenuse leg theorem. Okay, so we have in triangle MAC, AH is the perpendicular bisector of MC. What congruence theorem will prove that the two triangles formed by a perpendicular bisector are congruent? So we can use the leg angle theorem or HL. So we most of the time we can use AL or LL, leg. It's a leg theorem. Okay. Okay, let us continue. Which of the following properties justifies a statement? Segment BD is congruent to BD. That's the reflexive property. Ne- Okay, so we have here, this is the I don't know, the graph. So we have here uh, VV. Ito, VV bisects angle AVR. ABR, okay, and it is ABR is 10x and ABE is 5x plus 2. Okay, so I think it's correct. No? Okay, we could say that, of course, 10x, it's reflexive. 10x is equal to 5x, right? 5x minus 20. Okay, so we have 10x minus 5x equals 20 or minus 20 plus, no, it's plus 20. So we have 5x 5x equals 20 divided by 5. X is equals to 4. Alright, so letter B. Okay, so in number 41, what is the measure of angle ABE? Okay, so ABE. Now, if your x is 4, we have 4 times or 5 times 4 plus 20. So we have 20 plus 20 equals 40. Yeah, alright. So the answer is B. Get eat. Okay, next. In 40, what is the measure of AVR? So 10 times 5 or 10 times 4, of course, that's 4. That is 40 kasi 4 times 10 is 40. Next, which theorem requires to prove that right triangle ABC is congruent to right triangle AFC? Okay. Given AC is congruent to EDF and angle D is congruent to angle A. Okay, so these are congruent angle. Alright, so we have, oh, okay, and AC. Okay, AC is congruent to, no. This one, AC is congruent to FD or DF. So that is angle or leg angle theorem. Yeah, leg angle theorem. Okay, next. Okay, so we have here AC is congruent to DF and okay, BC is congruent to EF. So this is a leg theorem. All right, here. If two triangles are congruent and the measure of angle A is 35 degrees, find the measure of angle. Of course, 35 then. Okay. Next, so for 47 to 50. Okay, so we have here triangle. We have given here triangle RST and then segment R is congruent to ST and SO bisects LS or TS bisects S. Ito. So prove that SO bisects RT. Triangle, okay, these are all given. G. Angle STO and angle TSO, that is reflexive. Mm. SO is congruent to US. Nice. That's also reflexive. It's just a reflection of itself. So R is 2 congruent to as congruence. So therefore, so this is 50. No. That means RO is congruent to OT. That is true. CP CDC. Congruent parts of congruent triangles are congruent.